Hello everyone. My name is Tanvi Sungade. I am a first year student from Vishwakarma Institute of Technology, Pune. Our today's topic for presentation is Basic Instruction Execution Cycle from the subject Computer Organization and Architecture. These are my group members Swadha, Varad, Tanvi, it's me, Pranay, Rugved, and Mohan. The contents for our today's presentation are what is instruction cycle, some important registers, fetch cycle, indirect cycle, execute cycle, interrupt cycle, and why do we require instruction cycle. What is instruction execution cycle? It is the basic cycle of our computer system. In this cycle, the computer system fetches the instruction from memory, decodes the instruction, and then executes the instruction. Instruction execution cycle is also known as fetch, decode, execute cycle. So here on the left hand side, a diagram cycle of instruction cycle is seen, which starts by fetching the instruction, then indirect addressing occurs, then it executes the instruction, and if interrupt occurs, it solves the interrupt. We will see all this cycle in detail in further slides. Some important registers to be known. MAR, Memory Address Registers. It holds the address of current instruction that is to be fetched from the memory or address in a memory to which it is to be transferred. In other words, we can say that it specifies the address in memory for a read or write operations. MDR, Memory Data Register, also called as MBR, Memory Buffer Register. It holds the content found at the address held in MAR or data which is transferred to the main memory. Also, in other words, we can say it contains the value to be stored in memory or the last value read from the memory. PC, Program Counter. It holds the address of next instruction to be fetched. IR, Instruction Register. It holds a machine instruction that is currently being executed.
Hello everyone, I am Pranay and I am going to explain the fetch cycle. This is the first cycle of the instruction cycle. So, what is fetch cycle? In fetch cycle, the CPU retrieves the instruction from the memory. The instruction is typically stored at the address specified by the program counter. The program counter is then incremented to point to the next instruction in the memory. A simple fetch cycle consists of three steps. Step 1. The address in the program counter is moved to the memory address register, as this is the only register which is connected to the address lines of the system bus. Step 2. The address in the MAR, that is the memory address register, is placed on the address bus. Now the control unit issues a read command on the control bus, and the result appears on the data bus and is then copied into the memory buffer register. Program counter is incremented by 1 to get ready for the next instruction. These two actions can be performed simultaneously to save time. Say step 3. The content of the MBR, that is the memory buffer register, is moved to the instruction register. This is the fetch cycle of the instruction cycle.
Hello everyone, I am Rugved. Now I am going to explain you the indirect cycle. So what is indirect cycle? Once an instruction is fetched, the next step is to fetch source operands. Source operand is being fetched by indirect addressing. It can be fetched by any addressing mode. Here it's done by indirect addressing. So register-based operands need not be fetched because once the opcode is executed, a similar process may be needed to store the result in main memory. So as you can see, indirect cycle is being executed in three steps. So I will be explaining them. So first of all, the first step, step one, the address field of the instruction is transferred to the MAR. This is used to fetch the address of the operand. So now step two, the address field of the IR is updated from the MBR so that it now contains direct addressing rather than indirect addressing. Now the last step, step three, the IR is now in the state as if indirect addressing has not been occurred. So friends, note here that now our IR is ready for the execute cycle, but it skipped that cycle for a moment to consider the interrupt cycle. So this was our indirect cycle. Hope you like it.
Hello, I'm Swada. I will be telling you about execute cycle. In the execute cycle, the CPU performs the operation specified by the instruction. This may involve reading or writing data from or to memory, performing arithmetic or logic operations on data, or manipulating the control flow of the program. Let's take an hypothetical example. Consider an addition instruction, add r, x. Here, this instruction adds the content of location X to register R. This is done in 3 steps. So we begin with the instruction register containing the add instruction. Step 1. The address portion of IR is loaded into the memory address register. Step 2. The address field of the IR is updated from the memory buffer register, so the reference memory location is read. Step 3. Now the contents of R and memory buffer register are added by the ALU. The other 3 cycles, fetch, indirect and interrupt, are simple and predictable. Each of them requires simple, small and fixed sequence of micro operations. In each case, same micro operation are repeated each time around. Execute cycle is different from them. Like for a machine with n different opcodes, there are n different sequence of micro operations that can occur.
So, the next part of instruction execution cycle is interrupt cycle. In some CPUs, interrupt handling may occur during any cycle of the instruction cycle. An interrupt is a signal that the CPU receives from an external device or software that requires immediate attention. When an interrupt occurs, the CPU suspends the current instruction and executes an interrupt handler to service the interrupt. At the completion of the execute cycle, a test is made to determine whether any enabled interrupt has occurred or not. If an enabled interrupt has occurred, then interrupt cycle occurs. The nature of this cycle varies greatly from one machine to another. Let's take a sequence of micro-operation. So, first step is contents of the PC is transferred to the MBR so that they can be saved for return. Step 2 is MBR is loaded with the address at which the contents of the PC are to be saved. PC is loaded with the address of the start of the interrupt processing routine. Step 3 is MBR containing the old value of PC is stored in memory. Note that in step 2, two actions are implemented as one micro operation. However, most processors provide multiple types of interrupts. It may take one or more micro operations to obtain the save address and the routine address before they are transferred to the MAR and PC respectively.
Hello everyone, my name is Varad and I'll be explaining you about the significance of instruction cycle. The basic instruction execution cycle, also known as the fetch, decode, execute cycle, is a fundamental concept in computer architecture that has significant importance in modern computing systems. Some of the key significance of the basic instruction execution cycle are: the first one is instruction execution. The basic instruction execution cycle is the process by which computer processes instructions. It is the foundation of all computing systems, from simple embedded systems to complex supercomputers. The second one is improved performance. Understanding the basic instruction execution cycle is crucial for improving the performance of computer systems. It allows designers to optimize the hardware and software of the computer system to execute instructions more efficiently. The third one is complex algorithms. The basic instruction execution cycle allows the implementation of complex algorithms in computer systems. By breaking down complex operations into simpler instructions, the computer can process them more efficiently. The fourth one is interrupt handling. The basic instruction execution cycle also provides the capability to handle interrupts. Interrupts are essential for modern computing systems and allow them to respond to external events such as user input, network traffic, or hardware failures. The fifth one is improved understanding. Understanding the basic instruction execution cycle is essential for gaining a deeper understanding of how computer systems work. It is a key concept in computer architecture and provides the foundation for learning more advanced concepts in computer science. So thank you everyone. This is from our side. I hope you like this video. Thank you.